Welcome back again, everyone. Oluwaseun here. Today, we're going to continue in our Docker series, and we want to look at some Docker commands, all right, as well, that I believe it's going to also add to the knowledge that we have gained so far, okay? We're going to be looking at a few commands, all right? We're going to be looking at dockercreate. We're going to be looking at dockerimport and dockerexport command. We're going to be looking at different things, right? For example, if you want to limit the CPU consumption of your container, if you want to limit the memory consumption of your container, how do you do all of that, right? You don't just want your Docker container to basically just use, the CPU that you have available. Perhaps you want to restrict, all right, that container to maybe, let's say, 512 MB of RAM, and you want to restrict it to just use maybe one core of your total CPU. All right, so we're going to see how exactly to do that in today's video. It's not going to be a long video, it's going to be a short one, but of course one that promises to help to push our knowledge even further, all right, in this particular Docker series. So without wasting much of our time, let's get right into it. Now here we're still going to be using the node image that we've been practicing with, all right, during the course of this series. Now the first command that I want us to look at is the dockercreate, all right, command. Now we are all familiar with docker run, okay? Docker run, so you can say docker run. You pass all the parameters, -d, -p, the name of the container, the image you want to run, -rm, if you want to map a volume, you can also do that, right, with docker run. Now, one of the things with docker run is that docker run actually does two things for us. When you do docker run, if the image you are trying to run is not available, all right, on your system or within your Docker engine, docker run is going to pull that image and is going to start a container from that image automatically. That is what docker run is, all right? Now, of course, I'm sure you know there's Docker pull. So Docker pull basically is you're pulling an image from Docker Hub or from any, all right, image repository. And when you pull the image just remains there, all right? And then you can run a container from that image. You can run that image rather as a container by using your docker run command, okay? But then docker run can do all of that for you. So docker run can pull and run that image as a container at the same time. All right, but then there's also dockercreate, which means you can actually create a container from an image, right? Now, the only difference between docker run and dockercreate is that now while docker run is going to start the container immediately with all the parameters that you've specified, dockercreate will only create a container, all right, from that image without running, all right, that particular container. Which means it's just going to be more like, let's call it a dormant container, right? But that dormant container also can contain all the parameters that you could have passed in if you're doing docker run, which means I could attach my volume, I could attach the CPU limitations, the memory, all right, restrictions and all of that, even with dockercreate. Okay, the only difference is that dockercreate is not going to start the container, it's only going to create a container that is just idle until you use another command to start, all right, that container. Is that okay? So that is what dockercreate is going to do for us. So let's get started. So now I don't have any image like that we can use. So I'm going to build an image from this Docker file. So I'm going to say docker build -t, and let's just call this num-gen. Just any name, all right? And then we can just say v1 dot, all right? That will build an image for us. Now we have an image, so if I come and I do docker images, I can see now that I have a num-gen, all right, image. So now if I do not want to run this image immediately, maybe I don't want to run this image as a container just yet. Perhaps there's still some things that we want to do as a team and all of that. But of course, I just want to create a container from this image so that perhaps if we want to start, all right, the container at a later time, it's going to be pretty easy for us to start. Okay, so that is one of the purpose of using the dockercreate command. Okay, so now I can come here and say dockercreate. Okay, now from our knowledge of Linux, you already know that, I mean, even if you don't know all the parameters and options that you can use with a particular command, you can always use your -l to check, all the options that you can pass in, all right, to that command. Is that okay? And these are the different options that you can actually pass in, right? So there's the add host, I mean, a lot of options, okay? So what we're going to do here is I'm just going to say Docker images to basically know the list of my images. And then I can say Docker create. All right. Now with Docker create command, you cannot use -d because -d basically means to run a container in a detached mode. But in this case, we are not running a container. All right. We are basically creating a container from an image. So the container is not being run. All right. At this point in time, we are only creating an idle container from an image. Okay. So the -d command or the -d parameter is not going to work in this case. Okay, but then for the other ones, you can actually pass it in. So for example, I can say -name, the name of my container when I decide to start it up. So that can be node -nomgen, that's the name. And I can also put in my -rm so that, I mean, later if I decide to start this container, then if I stop it at a later time as well, the container should not only stop, but should be deleted as well. So I can pass that in also, all right? And then I can also pass, I mean, some other commands like your -p, which is, all right, a port. So I can say my port is 3000. And another thing that we can also pass in is also the CPU parameter. So for example, this my application, I mean, I don't want it to consume, all right, all the CPUs that I have on my system. I want to limit it to maybe just one core of the entire core, all right, that I have on my system. So one core will be like maybe 100% of. So for example, if I have like 4 cores and I say that these particular containers use 1 core, so that means it's going to use 100% of the 400%. So the 4 core you have is like 400%. And then when you say you're using 1 core, it basically means just using one, all right, on 100% of the 400%. So just like maybe 1/4, all right, of the total CPU. So that's what you're using, okay? So I'm going to come and say -CPUs, all right, is S equals, all right, and then I say 1. All right, let's say 1.0. All right, so that's more like 1 core. Okay, so like I said, if you have 4 core, you are basically saying my containers use 1 out of 4, all right, of the 4 core. So that is 1/4. Is that okay? And then here, I can also specify the memory. All right, so the memory also can be, let's say 512 MB. All right, so that'll be 512 M. Okay, so that's the amount of RAM that I'm willing to allow this particular container to use. Is that okay? Now, what are the other things that we can also, pass in here? So we've passed in the name, we've passed in RM, we've passed in the port number, the CPUs, all right, that we want to also run, that we want the container to start with, and then the RAM also we specified all of that. Now, the next thing we can do now is to specify the image that we want to create a container from. I mean, if you look at what you have here, it's similar to the docker run command, okay? The only difference is that we're not starting this container, we are only creating a container from an image. Is that okay? So now I can specify the image. So I can say the image is nomgen : latest. All right, that's the image that I want to create a container from. And then I'll press enter. Okay, all right. So now it's saying what? Unable to find image locally. Look at what I did. The image we have locally is actually, the tag is what? Is version 1. We don't have any image that is called latest. So that's why it returned an error. All right. So the tag is what? V1. And then I press enter, and now my container has been created. Now, if I come here and I say Docker PS, I don't have any running container. I have only created an idle container, okay, which I can start at another time, okay, at a later time. Is that okay? But of course, if I do Docker PS -a, I can actually see the container there, and it says that the container was created 18 seconds ago, and the status is what? The status is created. Okay, so it's not exited, all right, it is what? Created, which means this container was actually created from an image. It wasn't as if it was exited or something happened to it. No, we just created what I call an idle, all right, container. That is what we have created. And so if I want to start this container, how do I start it? I can basically say docker start, okay, and then I can pass in the name of the container or the container ID. And since we have learned the importance of giving our container a name, we're basically just going to use the name. So I'm going to say node-nomgen, and then I'll say start. And now my container that I've created has now been what? Started. So now if I do docker ps, I can see here that my container has actually now been started. Is that okay? So docker run, we already are familiar with that, but now we're looking at docker create, and we can see that with docker create, we're able to do, just create a container, all right, from an image. Okay, which means we don't necessarily want to run that image as a container at the moment. We only want to create a container from the image. Now, all the parameters that we passed in, the CPU parameter, the memory parameter, can also be passed in, with docker run as well. All right, you can also pass it in with docker run, okay, command. Now, if you come here to the docker desktop, and if you look at this running container, all right, if I click on this, I can actually, oh, sorry, that's the image. So let me go to the container. So this is the container. If I click on this container and I click on stats, which is the container statistics, is that okay? So I can actually have an idea of some of the limits that we set from here. For example, like the RAM, I can see that, okay, this container is not allowed to use more than this RAM. So if you look at what you have here, all right, it basically tells us that the limit for the memory usage is what? Is 512 MB. All right, and that is because, we specified that particular limit. Is that okay? Now, for the CPU, we have 1% here. All right, that you may not be able to tell the actual, all right, CPU consumption because we're not even, accessing the container at the moment. But of course, for the RAM, you can actually see the limits. And it tells us that here it is using 24, all right, 0.9 MB, okay, of the limit, all right, for the RAM. Is that okay? So you can actually see that that limitation actually works. So we can see that this particular container cannot go above 512 MB of the RAM that we have specified. Is that okay? So that is basically docker create and docker, all right, start command right there. Now, another command that I also want us to look at is what you call the docker commit command. All right, docker commit command. Now we're going to talk about docker export and we're going to talk about docker export as well. But let's take a look at docker commit command. Now, and I'm going to explain that to us in this slide. Now, on AWS, when you have an EC2 instance that is running, you can actually create what you call a snapshot from your EC2 instance. And then you can also create what you call AMI from that instance, right? So you can create a snapshot. Now that snapshot, you can later create a volume from the snapshot, and you can also create an AMI from that snapshot at the end of the day. But basically, the idea behind creating a snapshot from your instance is to basically have a backup of that instance, just in case something happens to that instance, and then you have to recreate the instance again with all the things that you've actually installed on that machine. You are able to quickly recover and then get your instance up up and running in no time. Okay, so in Docker you can also create what you call a Docker commit, which means you can actually create, all right, an image from a running container, all right, and then just have that within your Docker engine. Now, the only thing with docker commit command is that the image you create from that running container, or maybe, any container that you have really, is that you really cannot export, all right, that image. It only remains within, all right, your Docker engine. Okay, and that is where docker export and import comes into the picture. Because with docker export, you can actually export your container as a tar.gzip, all right, file that you can actually copy and then import into another environment, all right, and then create a container, all right, that has the same things as the container that you actually exported. Is that okay? But let's take a look at the docker commit command and basically see, all right, how to create an image from, all right, our container. Now I have a running container. Now, do I stop the container, or do I stop it? Or do I, what do I do? All right, can I just do docker commit while my container is running? So let's give that a try. So I'm going to say docker commit. All right, so docker commit is the command, and I'm going to use the container name or the container ID. So let's go with the container name. So the container name is node-num-gen. Is that okay? Now, docker commit. So this is the container that I want to create an image from. So how do I create an image from this? So I can come and say node, all right, colon v2, okay, or I can say node-num-gen colon v2. So that's the name of the image that I want to create from this container, and then I press enter. Now look at that. So I have docker commit node-numgen, which is the container that I have running already. All right. And then I have node-numgen version 2, which is the image that I've derived from the running container. So now if I do docker images, docker images, okay. Now look at what we have here. So Docker images, I can see right here that I have a new image, all right, that I've created from that container. So the container was running. I didn't have to stop it, all right, but at the same time, I was able to create an image from the already running container. So you can think about Docker commit more like, you creating a snapshot, all right, of your container. I mean, you can think about it like that. Okay, so that is what docker commit does. So we can see that we have another image from that running container. So which means whatever it is that we have installed inside of that container, whatever operations that were performed inside of that container, all right, this new image actually contains all of that. Okay, it actually contains what? All of that. But like I said, the only drawback to this is that we can actually export this outside of this environment, and that is where your Docker exports and your Docker imports, all right, comes into the picture. Is that okay? So let's take a look at our Docker, all right, desktop. So if I click on images, I can actually see my numgen, all right, and it says unused right here. Is that okay? So let's take a look at the Docker exports and the Docker imports, all right, command. Now here I can say Docker exports. So what am I trying to export? Now here you can export a container as well. So I want to export my container more like you're taking a backup. Like I said, it's more like you're creating an AMI, okay, from your container. All right. I mean, that's what it's like, okay, because on AWS you have an EC2 instance, you can create an AMI from that instance, you can create a snapshot, all right, from the instance. I mean, just to make sure that you have a backup of your EC2 instance, so that in case the EC2 instance, something happens to it, all right, the time it will take for you to recover and to get another instance running, all right, will be greatly reduced because you already have backup of that instance. So Docker export is also something similar. So here, the name of the container is, so let's take a look at the container name again. So Docker PS, all right, so we say Docker exports. Okay, so the name of the container is node-numgen. All right, now, one of the things that I need to mention here is when you're trying to export a container, all right, as, maybe, as a tar.gzip file and all of that, it is actually a good idea to stop the container. Okay, but then, when we're creating this container, we specified -rm. And the moment we stop this container, it is actually going to be what? Deleted. So let's try and see if Docker exports will work without stopping the container, or we're going to get an error. Is that okay? So let's give that a try. So the name of the container is node, all right, numgen. And here I'm going to pass in, some parameters. So I'm going to say, all right, here, gzip. I mean, assume you have your gzip installed. Now, if you're using git bash on Windows, you can actually use the gzip command because it comes with your git bash. All right, but if you're on Linux, I mean, you can install gzip or you can check if it is already installed. But on Windows, if you're using git bash on Windows, gzip, all right, is already part of the program that comes with your git bash, all right, already. So I'm going to say gzip-z, and I'm basically just going to put this, arrow sign, and I'm going to give my image a name. So I'm going to call this, what should we call it? So let's call this node, all right, -numgen, and then we will say .tar.gz. Is that okay? So that's the export name, okay? And let's press enter and let's see what happens. So I am creating that package in my current working directory, and I didn't stop my, all right, container. Now, ideally, you are supposed to what? Stop your container. But because of what we're doing, all right, and because of the way we created the container, that is why we are not stopping the container. But normally you're supposed to stop your container and then create, all right, an export or a commit, all right, from that container, and then you can start the container again. The reason why you need to stop the container is to be sure that, I mean, your container is stable, and then all right, you're copying, data, okay, that are stable and all of that, right? Because, I mean, let's assume that somebody is performing an operation, okay, on this container at the moment, and I'm creating an export or I'm creating a commit, that means there are certain data that may not be captured, okay, because the container is running. But when the container is stopped, I mean, no operation is going on. So whatever I capture at that point is actually the true state, all right, of the data inside of my container. But when the container is running, you can't be sure that, I mean, you've copied the true state and everything you've copied is actually, all right, you know, true, and I mean, nothing is missing. Is that okay? But if you look at what we have here, we have the node, all right, tar.gz, and so we've been able to export, all right, you know, our container, all right, as a tar.gz, all right, you know, file. Is that okay? And so the beauty of this now is that I can actually copy this and of course go and create my container in another environment. That's the beauty of this, okay? But with the commit command that we saw earlier, we can actually do that because, I mean, the image that we created from the container basically is within the Docker engine. But with this now, I can grab this tar.gz, go to another environment, and basically import this particular, all right, file as a container in that environment. So let's see how to do that. So I'm going to come here and say docker import. I mean, let's assume this is another environment, okay? So it's going to be docker import, and it's going to be node-numgen, all right? I mean, that's the name there. And of course, you have to create an image first, okay, from these exports, and then you can now run that image as a container. So the image name is going to be node, all right? So let's just call this second, all right, env. I mean, just something fun. Okay, and then version 3. Is that okay? And then I press enter. So basically, it is going to take that tar.gz file, you know, extract it, and then create an image from that. So now if I come and I say Docker images, all right, I can see here, all right, node second env v3, all right, 5 seconds ago, and I can see that the size of that image kind of reduced. Okay, do you see that? It kind of reduced, you know, to 170 MB. I mean, the original image was actually 183 MB, but then, you know, the compression method that which is the gunzip method, all right, actually maybe reduce the size even further. And now we have 170 MB, right? So that is how to export and to import, all right, a container into your Docker engine. So you can export a container as an image, all right, as a form of a tar.gz file, and then you can import that tar.gz file as an image into another environment, and then use that to run, all right, your container. But of course, like I've said, when you are trying to do Docker commit, Docker export, and these things, make sure that you have stopped your container before you perform, all right, these operations, okay? So that you're sure that, I mean, there won't be any issues at the end of the day. So thank you so much, and I'll see you on the next one.